Hello, everyone. Welcome to the Masons Online Classroom. Today, I'll share with you the fundamental knowledge of architectural drawing recognition, Part 4. In the previous lesson, we delved into how plans, elevations, sections, and detailed drawings are formed in architectural construction drawings and their respective functions. In this lesson, we will specifically learn about the methods, steps, and key points of interpreting drawings. The drawings drawn in the architectural plan include the building map title, drawing scale, the axial line of the building, and the location, shape, quantity, layout and number of doors and windows of the room, and the setting dimension and elevation of other building components and fittings such as canopy, etc., as well as the detailed drawing index and section symbol, north arrow and text description, and the roof shape and the above accessories. Taking an example of an architectural plan drawing, let's first examine the ground plan of the building. Information to be extracted from the ground plan includes the map title, scale, building orientation, internal room layout and dimensions, and floor elevations and such. Apart from the content found in the ground plan, standard and top floor plans follow the same formation principles. To simplify the drawing process, elements already represented in the ground floor plan, such as aprons, drainages, and outdoor steps, may not be reiterated in the standard and top plans. The canopy shown on the second plan shall not be drawn on the top plan. Reading the standard and top plans should focus on comparing similarities and differences with the ground plan, including changes in layout, variations in wall thickness, alterations in floor elevations, modifications in stair symbols, etc. The roof plan is a horizontal projection above the building's roof. It indicates the positions of roof skylights, water tanks, iron ladders, ventilation ducts, parapet walls, deformation joints, and more. Additionally, it includes symbols for features like parapet walls or eaves gutters, roof drainage zones, drainage directions, slopes, and the positions and dimensions of rainwater outlets. The content of the architectural elevation drawing includes the map title, scale, axial lines, the charts that make the building elevation drawings clear and beautiful, and 3 dimensions composed of detailed dimensions, floor heights, total height annotations, door and window legends, and elevations. Taking a specific architectural elevation drawing as an example, the map title is labeled as 1/8 elevation, with a scale of 1:100. The indoor-outdoor height difference is 0.3 meters, and the floor height is 3 meters. Moreover, the building has 4 floors, and the window sill height is 0.9 meters. A cantilevered canopy is positioned at the main entrance with a 2-step platform. The elevation has a regular shape and simple design, and exterior walls are adorned with 100 by 100 yellow glazed tiles, while the window sills are decorated with 100 by 100 white glazed tiles, and the eaves feature golden glazed tiles. The architectural section drawing includes the map title, scale, axial lines, and dimensions. It illustrates cut sections of the roof, floors, interior and exterior ground levels, as well as cut sections of internal and external wall structures with doors and windows. Additionally, it displays various load-bearing and connecting beams, stair sections, stair platforms, canopies and their beams, balconies, corridors, and more. It also shows visible parts that are not cut, visible beams, columns, visible water chutes and rain pipes, visible skirts, and interior decorations, along with vertical dimensions and elevations and detailed drawing index symbols. Taking a specific architectural section drawing as an example, in combination with reading the ground floor plan, the interrelation between the section drawing and the plan drawing establishes a spatial concept of the building's interior. By reviewing the architectural design specifications or material practice tables, details of the finishes for the ground, wall, floor, ceiling, etc. can be found. Based on the dimensions and elevations of the section drawing, you can understand the floor heights, total height, number of floors, and the height difference between indoor and outdoor surfaces. Understanding the connections between architectural components. Understanding the structure of building roofs and the formation of roof slopes. understanding the vertical positioning relationships of load-bearing components such as walls and beams. Detailed drawings in architecture include index symbols and component details. The relationship between detailed drawings and plan, elevation, and section drawings is established through index symbols. The leader line of the index symbol is extended in the horizontal diameter direction, pointing to the referenced positions. There are three types of index symbols: detailed drawing index symbols, partial section index symbols, and detailed drawing symbols. The top half of the circle on the index symbol represents the detailed drawing number, while the bottom half indicates the drawing number of the construction drawing where the detailed drawing is located. If the detailed drawing and index symbol are on the same sheet, they are connected by a horizontal line. Detailed drawing symbols can be expressed with or without an index on the same sheet. Taking a specific wall detailed drawing as an example, the method and steps for reading the drawing include first understanding the scope represented by the wall section drawing. When reading, it is necessary to combine the index symbols annotated in the ground floor plan to identify which wall the section drawing pertains to. Then, understanding the layering method in the drawing, such as the representation of ground practices, where the order of text annotations corresponds to the sequence of the graphics. This method is commonly used for ground, floor, roof, and wall finish practices. Next, you need to understand the relationship between components and walls. The relationship between the plate and the wall is generally divided into two types: against the wall and pressing the wall. The left diagram illustrates against the wall, indicating that the wall is non-load-bearing. Combining the reading with architectural design specifications or material practice tables helps understand the detailed construction methods. It reveals the relationship between door and window openings and wall structures. In construction projects, there are three ways to position door and window frames, namely, flat inner wall, flat middle wall, and flat outer wall. Detailed drawings also indicate the detailed finishing and waterproofing methods for various parts, such as drainage ditches, aprons, damp coursers, window sills, eaves, and gutters. The second type of detailed drawing is the stair detailed drawing. Taking this drawing as an example, the first step is to identify the axis number and understand the planar position and vertical direction of the stairs in the building. Determine the dimensions of various parts of the stairs, including the size of the stairwell, stair sections, tread width, and plan dimensions of resting platforms. Read the height of each part of the stairs in combination with the section position and projection direction marked on the plan, including the elevations of grounds, resting platforms, floors, risers, door and window openings, as well as the heights of stairwell, railings, and handrail. Interpreting architectural drawings requires skill, and attention to detail is crucial. Here, we summarize the steps for reading drawings. Understand the overall picture. Familiarize yourself with common symbols and annotations on architectural drawings. Grasp the overall structure and layout of the building. Pay attention to indexes and leader lines on drawings. Identify relevant details and cross-reference with other professional drawings, e.g., structural, plumbing, electrical, to gain a comprehensive understanding of the building. That concludes our lesson for today. Thank you all for watching.